Good morning, everyone. I'm Yukui from University of Strathclyde. Today, I would like to introduce my research during Microman project. My presentation title is Nanosecond for the laser ablated functional surface on AISI 316L stainless steel. I will introduce the background research challenges, two kinds of functional surfaces like superhydrophobic surface and antimicrobial surface will be introduced, and the conclusions. Superhydrophobic surface means the surface has a contact angle larger than 150 degrees. It is because the surface has low energy. However, in artificial or natural materials, the maximum intrinsic contact angle is only approximately 120 degrees. In order to further increase the contact angle, we need to develop suitable microstructures to realize the Castle-Baxter model. Actually, superhydrophobic surface inspired from the nature, like a lotus leaf, has a self-cleaning function due to the micro-nanostructure on the surface, and the insect can survive from the extreme environment due to its wing has micro-nanostructure also. And the superhydrophobic surface can use the anti-icing application, anti-blood adhesion, and our life like self-cleaning clothes. And for antimicrobial surface, silver nanoparticles is a common material to kill the bacteria like this video. And it also has been widely used in a range of medical device coating. So what's the challenge? For superhydrophobic surface, how to design appropriate microstructures and develop a low-cost, high-efficiency manufacturing process is critical for the industry-scale application. And for antimicrobial surface, normally it use a lot of chemical reagent. How to reduce in type of chemical reagent in the preparation process is critical, and also a low cost and a high efficiency process is also required. In my research for superhydrophobic surface, I use MATLAB to design the microstructure first. The shape of the structure is according to the shape of the laser beam, and then use the laser to make the microstructures, and then use the chemical reagent to reduce the surface free energy, and the contact angle measurement device used to test the contact angle. This is the machine used in my research. It includes a nanosecond laser, like this photo. And the machine result shows that different surface has different contact angle. For the small surface, the contact angle is just 105 degrees. However, for the surface with pitch of 110 microns, it has a contact angle 153 degrees. It can be called a superhydrophobic surface. These two videos show the low adhesion property of the superhydrophobic surface, and we also use a high-speed camera to record the video of dynamic behavior of water droplet. And for small surface, the water will adhesion on the surface, and for superhydrophobic surface, the water will rebound on the surface, shows a very low adhesion property. And for antimicrobial surface, we developed a new process called structure coat. It means when laser do the structuring on the surface, it can realize coating, which means the micro drops of silver nitrate solution generated from ultrasonic atomization will be decomposed due to the laser machining area has sufficient heat energy. Like this photo, the drop of silver nitrate solution will finally decompose to silver nanoparticles and adhesion on the structures. Then we do the experiment, at different laser power and found that 14 watt is a best parameter for laser power in this experiment because the silver nanoparticle is very weak. And then we use different concentration of silver nitrate to do the experiment and found that 15 micromole solution of silver nitrate is the best condition, and the silver nanoparticles showed a very good quality. And XRD proved that silver nanoparticles on structure coated surface and on laser machined surface and smooth surface there are no silver. And we count the diameter of the particle and found that the size is around 500 nanometer. Then we do the antimicrobial test and found that for structure coated surface, it has an antibacterial rate 186.2. So the microstructure can help the adhesion of the silver nanoparticles. It will release cell ions and kill the bacteria. So we can conclude that for superhydrophobic surface, laser ablation method is a low-cost method that's suitable for industry-scale application. And for antimicrobial surface, structure coat is an eco-friendly process due to no requirement of reducing agent and stabilizer agent, and only silver nitrate is required in the decomposition process. This is the reference list. Thank you very much.